So this is kind of an important notion. So okay, so a couple of things. This is just to represent a normal distribution. You might start seeing the Greek letter mu, okay, and it's basically the mean, okay, the average, okay. When you see the Greek letter mu, this means that you're talking about a population mean. And then you might also see, and you've already seen this, this Greek letter here. I mean, this is a standard deviation, but usually when you see it like that, it's talking about a population as well. Population. Okay, now things to know that will work. We know the z-score equation is observed minus the mean over the standard deviation, correct? And I'm just writing it as mean and SD for standard deviation because we could have it as x bar. We could also have it as mu, and then standard deviation, you know, basically the same. So if you are given a mean of say 50 and a standard deviation of 6, and then they ask you if someone scored I don't know, let's say a 59.5. Okay? So we can find that z-score. Do you agree? We'd go 59.5 minus 50 divided by 6. Does that make sense? But we could also do it one of two ways. Okay, we have our normal distribution. If we did it this way, we could plot this on Desmos. We could have this as 50. This is 56. And then our 59.5 might be, oh wait, it's wrong spot. Stirrup can't count. We have our 59.5 is right here. Okay? But well, let's just do this first. We're going to do this on Desmos and just take a look at it and verify that we're going to get the same answer. So if you wanted to play along on Desmos, go for it. Come on, baby. Find it. Something's going on. Who broke it? There we go, Desmos. All right, so we had the normal distribution. So we go and find normal distribution and functions. Hey, Bob. Hey, Bob. We're on page 75. So we said our example was we had a mean of 50, a standard deviation of 6. Oh, wait. Why did I hit histogram? I'm sorry. I hit the wrong one. Normal distributions are on. So if we go 50, 6, if you hit the plus button, it's going to take us out to make it appropriate on there. And we said if we wanted to know, you know, how much better did we do than the rest of the people, we would put 59.5 in here, and it's going to give us 0.943. Okay? So I'm just going to write that down so you have it as something to refer back to. So this means that we did better than 94.3% of the population. Okay? Now, if we go back, hey, good to see you, Bob. We go back to our information. Let's find the z-score of this. And I need someone to do this math for me, please. So I'm going to take my 59.5 minus 50 over 6. So would somebody go 9.5 divided by 6 and let me know what you get? How much? 1.583. Cool. So that's our z-score. Okay. So I'm going to take, so 1.583. So I'm going to go back to Desmos, and I'm going to create another normal distribution down here. I think I can do 2 of them. We'll see. But here I'm going to say my mean is 0, my standard deviation is 1, and I want to plug in the z-score of 1.583. So notice between the two answers, the answer is identical. Okay, so here's the key when you're working with a normal distribution. You're welcome to use Desmos and say, oh, it gave me the mean, gave me the average, and it gave me the standard deviation, and it gave me the score. And that's going to work for your normal distribution. So if you go back to your normal distribution, this is what that normal distribution looks like. Okay? If you chose to find the z-score and change the normal distribution, or change the mean to 0, standard deviation to be 1, and then you plug in the z-score, it just becomes the same thing. It's the same graph. It's just this one is centered around 0, 0. The other one is centered around 50, 0. Does that make sense? So again, when you take a look at it, I'm plugging in 59.5 because that's my observed, that was what my score was. If I plug in 1.583, that becomes my z-score of 59.5 with this and this. But notice how it's a little bit different with how I plugged it in to choose which is the right way. Well, my gosh, 943. So this one is a little bit, once I get out to 4 decimal places, it's a little bit tweaked different. But when we're doing stuff, we're only really going out to 3 decimal places. So should you do it the top way or should you do it the bottom way? And I'd say as far as this class goes, you could probably do it either way. I would imagine if you were to get into some real in-depth statistics class later, you would probably want to keep the top one because it's more of an exact answer based on the data that's given, not based on just normal distribution centered at 0. Okay, so there's just some things that take place now. The standard normal distribution is the distribution of z-scores, so that's why we could use the z-score, always with a mean of 0 and a standard deviation of 1. However, many normal distributions exist in various contexts. Real-world examples are provided. IQs are normally distributed with a mean of 100 and a standard deviation of 15. Lengths of typical pregnancies are normally distributed between 268 days with a standard deviation of 15 days. Heights of adult males are normally distributed of 69 inches and a standard deviation of, they're saying 2.5. We've been using 3. I don't think it ruined anybody doing that. How many other variables are normally distributed or close to normal, that the bell curve makes an effective model. Okay, so these are the directions. If you had used a graphing calculator, what I have up on the board is how you would use Desmos, which I think most of us are using Desmos. It talks about the Greek symbol mu represents population, and the Greek letter sigma, lowercase sigma, or lowercase phi, excuse me, represents population standard deviation. So if you take a look at the overall IQs with a mean of 100, standard deviation 15, if somebody had 109, what percentile? Okay, when it says what percentile, you're asking about what x value on the x-axis would you be at, and that x-axis is actually the z-score. Okay, and then so each of these would be at the 94 percentile, or the 94.3 percentile, because I would just move the decimal 2 places to right to make it a decimal. Following so far? Make sense? We can calculate the percentage of normal distribution that is shaded by using the calculator command. So again, that's using what we're doing. They use something called normal CDF. We're using the normal distribution. They're basically going to be the same terminology, whether you use Desmos or the graphing calculator. So they found in our case that there's 72.6% of the population is below an IQ of 109. So that would mean that in that case for the IQ, somebody with a 109 IQ with the 115 being the standard deviation, that would basically mean that they would be at the 72.6 percentile. Okay, that's the area under the curve, percent area in the curve to the left. Okay, more examples provided with normal distributions. What are between 88 and 117? Okay, if you wanted to use this one that we're showing right now, you would have to find the z-score of 88, and you'd have to find the z-score of 117 and plug them into this. Or you could just do this. Let's get away from that. Go here. Let's change this to our 100 and, what did they say, 9 or 15? If you wanted to find between two values, you'd hit plus. If you wanted to find between two values, you could say, if you had somebody who had a IQ of 88 all the way up to somebody who has an IQ of 117, it's that area under the curve. So you're talking about 65.9% of the population would fall in between the two. Okay. Now did I plug that in wrong? 117, 88, 117, 66. Yeah, we're right. They got, okay, yeah, they round to 66. So we're right on with that. Now, that is not a percentile. That's not saying, hey, what percentile am I at? Because it's not the true area all the way to the left. It's bound. That's just saying that's the percent of the population that would happen to fall within that. So it's roughly 66% of the population would fall within 88 and 117. Okay? Ooh, hang on. I gotta sneeze. I feel blessed. All right. Let's see. What percentage IQs are greater than 96? So if I want to figure out what's greater than 96, I would have the bottom bound be this, and I'd have the top bound be infinity. And 60.5% of the population would have an IQ above 96. Okay. And then let's see, what percentage of IQs are less than 66? So if I made this 66 here, and I changed this to using negative and then typed in infinity, then you're talking about 1.2% of the population. Again, move the decimal 2 places to the right. And again, if you're looking at the board up there, it looks like it's a negative value. That negative is actually an equal sign. It just doesn't show up as clearly. So you could run through a whole bunch of iterations of that. Sometimes the proportion is requested not as a percent. A proportion is considered decimal equivalent to the percent. For example, 45% is equivalent to 0.45. 0.45 is the proportion. Proportion is a decimal form of a percentage in statistics. Note number 2, the sequel, unless otherwise indicated, we all round the answers to 3 decimal positions. Okay, so we'd already been doing that, so that's just as a reminder, we're just going to keep doing it. So that's not the hardest lesson, I don't think. Again, I think that Desmos is being a very valuable tool for all of you. So I need to go to 3635. Yeah. So let's have you, for next time, have this completed. Page 183, 184. And that's all I got for you. You have the rest of the period to work on it.